Alright, so let's go back to solving problems. Let's see. Yeah, so let's solve problem 10 first. If A is a non-negative integer, prove that A is congruent to its last digit mod 10. Alright, so yeah, let's see. So A could write it as bunch of multiples of 10 to the power of n, an, plus 10 to the power of n minus 1, an minus 1, all the way to 10 to the power of 0, a naught, and that is congruent to a naught mod 10. Simple and elegant. All right. So let's go to the next problem. Let's go to back to 9. Prove that you have A, which is n minus a squared. And this is congruent to a squared mod n. So n minus a squared, this is n squared minus 2an plus a squared, which is congruent to every element with n will be disappearing as that's congruent to 0. So that will be congruent to a squared mod n. Alright, and then b is 2n minus a squared is congruent again to a squared mod 4n. So like the general pattern is that if you have like certain factor multiplied by certain number, then that number gets squared in the mod, then that would be congruent to a squared. That's the general pattern. It's good to like, that's why you solve problems like that. So you connect and collapse pattern, you connect and collapse pattern, you connect and collapse pattern, etc. So you have a 2n minus a squared. This is equal to 4n squared minus 4n times a plus a squared, which is congruent to a squared mod 4n. Yeah. So yeah, I'll see you guys in the next video, and we'll be solving more problems. Bye now.